then what does YARN stands for? Yet another resource negotiator. Okay, so that's what we're going to see all together in today's session. So I'm more a visual person. Okay, so I believe I find it comfortable if I can see things or visualize things that makes my brain register much better. So, and I would take my sessions also in a similar manner, unless and until you guys don't want to do that. Yes, Vikalp. MapReduce also will be, what is Spark and Storm used for? We will be covering all this, Kaushik, when we slowly progress. So we're going to see ecosystems and things when we progress. So we're going to see that. MapReduce, yes, we are going to play around with MapReduce. You're going to dirty your hands with MapReduce. That's what's going to happen. Yeah, okay. All right. Yes, we are going to do that. All right. So first and the foremost, what the problem for us, let's spend some time on our problem. So let me take a paint. I'm using this paint because this dashboard, when I use the software provided by the dashboard, it is creating a lot of issues. So let me rely on this one. So I want you guys to answer some of those typical scenario which you're going to come across. All right. So, but I'm going to buy a laptop. Okay. So this is my laptop. Let me make it a little blue in color. This is my laptop, and let me use the text. And the capacity, the storage capacity for this laptop is maybe 1 terabyte. Okay, 1 terabyte storage capacity. Okay, now I have a video available with me. I do understand if it's not going to be a face-to-face and it's going to be a slightly off late session, you tend to either feel a little bit sleepy or if you guys staying alone might be thinking, what should I be cooking tomorrow? Idli with sambar or dosa? But make sure you have your complete attention towards it. Okay, once you miss slightly, you may be trying to target what the missing part, and you may lose the session completely. So the breakfast that you're going to cook tomorrow, we can see tomorrow. And slightly sleep for a couple of months, you guys too, because that's where you showed your commitment and joined for the sessions. Being that said, let's move on. Now, I just want to make sure everyone is awake from it. That's why I'm trying to be a little bit funny too. Okay. So now typical what our problem is, 1 terabyte, and now let's make it all together over here. Let's make it a slightly, what color is this? Sandal. Oh, this is my file. Okay. And this is a huge file for me. Maybe think of this is a blockbuster movie series of movies, and this is 2 terabyte for me now. Okay. Guys, in case if you're not on to speaking, I appreciate if you could mute yourself, because otherwise it may create. So when you listen to this recording at a later point of time, you may find a lot other noise coming up. So the time being, mute you guys, mute all, and continue. All right. Yeah. So in case if you don't want to discuss or anything, make sure you're putting your session on mute so that it's not getting, others are not getting disturbed because of it. Okay. So now 2 terabyte of movie file. And I have bought a new laptop, which is just 1 terabyte for me. Okay. There's no other alternative option for me. What I'm going to do is I'm going to buy a hard drive for myself. Let's make it a space so that everyone is counted over here. All right. Yeah. So I'm buying 2 hard drive, which is 500 MB. So make sure everyone is attentive to this 500 GB, because this is a core concept which we're going to discuss over here now. Another 500 GB. A very, very typical scenario. You might have faced this kind of an issue before. Okay. I have 2 terabytes of a movie which is 2 terabyte. Okay. Will I be able to store this particular file in this? And then what I did, let me connect it. Let's connect this hard drive to one USB port. I'm done. And the next hard drive. Oh, what's happening? Okay. I click outside. What's this? All right, that's okay. Another shape. Let's bring in Control Z. Shape. Let's bring in this. Okay, I connected this to my computer. This is my hard drive. I'm connected this hard drive too. So altogether, when I think of this ecosystem, I have 2 terabyte, right? 1 terabyte, 500 GB plus 500 GB. So I have 2 terabyte of storage space available with me. I have a file which is of 2 terabyte. Will I be able to store this particular file into my computer system? Will I be able to do this? No. Yeah. Oh. So basically what's going to happen? I'm going to have either, if I just double click on it, I can see in my C drive, H drive or something showing 500 GB, whereas my C drive is going to show me as 1 terabytes, right? So that's that will. And this is exactly some of those scenarios which you're going to see. Okay. So this picture is clear with everyone, right? This kind of architecture, we cannot store this 2 terabyte because of the reason it's our file, which is 2 terabyte, is not split or anything of that sort so that it can accommodate in this entire system. So in case if I wanted, I can maximum store 1 terabyte and then it will be directly placed in my C drive. Okay. Now let's move on to just have this figure in mind. Okay. We're going to come back to this. So now this is our big data problem now. So 1 terabyte of this thing, that's what we discussed. Now, the typical example which we saw over there, that's exactly how the Hadoop cluster works. Okay. So now let's read through it and then come back to that figure. Hadoop cluster works as follows. Data is broken into chunks and distributed to different nodes. Wherever you see a node, replace that with your computer or your laptop. Okay, that's as simple as that. One node is nothing but one laptop of yours. So when I say I make a cluster, what exactly I'm trying to do? I take 5 different computers, okay, and then loop everything together, make it in a LAN, and then I make a cluster. Okay. See what I mean by making a cluster. So each node, yeah, it's given as computer. Process data into storage. Okay. So we're going to see all these things more in a visual format. Where is my drawing now? Okay. So everyone fine with this environment? Let's bring in a new step. Okay. I'm sorry. I think someone else is doing some repair work at top of my home. All right. So basically what I want to do now is our typical, which we discussed now, shape and the shape, my big file now. Let's take an example of maybe 2 GB or something of that sort. Okay. And I have multiple computers. Let's make the computer blue in color. And this is the shape. So this is my computer. Computer 1, computer 2, computer 3. Okay, let's stick on to 3 as of now. So this is nothing but node, or my laptop or my computer. Okay. So the key funda that has been spoken about over here, data is broken into chunks, okay, and distributed to different nodes. Okay. So what does it mean? So this data, so the moment I get this particular, let's make this as 200 MB of file. Okay. Let me write that down so that you have registered stuff in your mind. 200 MB megabyte. Okay. So this file is 200 MB of file. So what exactly I'm going to do in my Hadoop environment, before a data is getting stored, first and the foremost thing that Hadoop is going to do for you is cut this file into predefined data size. Okay. So the moment a file comes into a Hadoop system, first thing that the Hadoop system is going to do is cut that file into into three different parts, or any number of different parts. So basically, I have defined it as slightly. You might be going off track right now. Don't worry. So you're going to get all those things clear. So I can define what sort of a size limit I want my files to be split in. Okay. So right now I'm giving it as 64. Okay. The next one is going to be another 64. Okay. And next chain is going to be 64 again, right? So I guess how much has become 180, 190. I'm assuming it's 192. Now that means I have one more file to be split. It's going to be a slightly smaller number, and I'll have, how much is left? 8, correct? So 8 MB file over here. Why is it not coming? So text. Yeah, now 8. Okay. So these are all MB, okay? I mean, megabyte, 64 mega, 64 MB, 64 MB, and 8 MB. Why did it happen? Because I have predefined in somewhere. So where exactly I'm going to write it, all those things you're going to deep dive into all the stuff in the later sessions. So maybe the third or fourth sessions, you're going to see all those things. But right now, try to understand this. I do have some space available for me where I'm going to tell, in my Hadoop environment, anytime any file coming up, I want that file to be split on 64 MB. Okay, how much of a big the file is, I don't care. Any file needs to be cut down into 64 MB, 64 MB, 64 MB, and the remaining was 8 MB. So in case if it would have been 300, again, this would have been 64, and the remaining part would have been left as such. Okay. Some concept, RAID partitioning. I don't understand. Is it not similar to RAID partitioning in Linux? I really don't understand what is RAID partitioning concept. So Kaushik, so in case if that is how it is, partitioning, I'm not sure. My knowledge on limited to big data Linux. So maybe, I mean, this is exactly the concept. Okay, so if that is a RAID concept is how it is, so maybe. But yeah, let me note that down. So I'll use this session for my learning purpose. So that's something new that I find. So RAID is something which I would like to Google. All right. Okay, so hope this concept is clear with everyone. So now what needs to be done? Let us name this stuff something similar to I don't know that too. Rack awareness you're talking about? Rack RS? Yeah, rack awareness. All right. No, you have some sort of an information on big data prior, and yeah, so rack awareness and all those things you're going to see later. All right, so let's name it A. Let's name this guy. Do you want to make it as pink? So let's make it as B. Let's make it as C. And make it as, and let's make this as D. All right. So what happened? I have split it up into 4 parts. Now, what is one part will be kept over here. Another part is going to be kept over here. Where is it? B, C, and D. Okay. Randomly, I have placed my files into this ecosystem and this. Okay. So that's exactly what it is. So is this concept clear? So A, B, C, D. So first and the foremost, I have split the file into equal chunks, and that's getting stored into a different computer in this way. And nothing but my Hadoop environment. Let's bring in another shape over here. Okay, this is my Hadoop environment. Okay, at a very, very high level. Hadoop environment with 3 nodes. Okay, just try to understand. This is my Hadoop environment with 3 nodes, nothing but 3 computers, and this is how exactly it's getting stored. And that's what's been said over here. Okay. Now the key concept behind what has been said is, the moment I have this data stored over here, okay, this computer, each computer by its own is capable of, I would appreciate if you guys, what you can do is make sure you're sending some technical stuff or something to everyone so that everyone do understand it. Okay. So now Tiwari had a question. What is the difference between node and cluster? So this is node. Okay. The collection of node is cluster for me. Okay. So 1, 2, 3, 3 nodes, and this is one single cluster. Hope that answers your question. So now, what we need to do now? Okay. So this computer is equipped enough to do some processing as well. Okay. So you can do a processing with this computer. What does it mean? You have a data sitting A and D over the first computer, B in the second computer, C in the third computer. This A and D part, small chunk of A and D, can be processed by this computer. B will be processed by this computer. C will be processed by this computer. Okay. And then at the end of the result will be sent back to the client. Sent back to the. So basically, one more computer we need, which is nothing but a client for me. Let's make a client actually different in color. Let's make purple or something of that sort. So this is the client. Okay. The request came from the client for some process of processing. So when I say processing, don't get too much confused in it because you're going to get covered more in detail in the later session. So this is just how exactly you need to understand in terms of storage, how exactly your files are getting stored in the Hadoop environment. Okay, that's all you need to know. So first and the foremost, split this into equal chunks. One will be slightly smaller than because of how exactly the math worked on it. Okay, and then here everyone is processing their own individual part which they got. Okay, and then they'll combine together all this process data and send back the result to the client. Okay, that might be a little bouncers or information for you guys. Leave about it. So we are going to cover that in detail when the real processing comes into the picture. Vikalp has a question. You told us that we can't divide the whole file, but in this example, you split it the 200 MB. Did I miss something? No. Perfectly right. You did not miss anything. Normally, you can't divide, but in Hadoop environment, you can divide it and solve the problem. Okay, great. So this is a great stuff. So yeah, Chandan has answered for Vikalp. So Hadoop environment is going to split in this Hadoop. That's a mechanism or that's architecture which is being followed in the Hadoop. So what it's been doing? So in our normal environment, we will be expecting this to get stored. The entire file will be stored in one computer or something of that sort. But Hadoop maintains it. And there are n number of reasons for doing it. Slowly, one by one, we are going to see what are those reasons. So first, Hadoop architecture, what does it do? The moment it sees a file, split it into 64 MB. Let's right now take an example of 64 MB. So any file is coming up, it's going to cut it into 64 MB and store each portion into each different computer. Okay. So hope this concept is clear for everyone.
Shazi, just a quick question.
Sure.
Tarun this side. Can you go back to the diagram? Yeah.
Yeah. Mm-hmm.
So with respect to this example, is this possible to divide 200 MB in such, in normal fashion, 64 plus 72, or you have some special mechanism by which you segregated it into 4 pieces and then assigning it to some three.
No, got your question. Good question. So no, first itself, what I'm going to say is I need to make up my mind how much is the size I want my file to be split. Okay, that I have been defining when I bring in those cluster in place. So what I'm going to say is in my environment, I'm going to have fixed 64 MB. Take all this with a pinch of salt. Okay, I mean, for the time being, you need to understand. You need to understand. But when we move, we may slightly deviate from whatever the concept I'm talking about. But right now, for you to understand, there is something known as a configuration file, which is you're going to mention the 64 MB in that particular configuration file. And that is how it's getting split to 64, and the remaining stuff is just 8. So I cannot have this 64, this 64, and this 72. No. So the maximum size which I can have is the one which is defined over here in the configuration file. Does that answer your question?
Okay, got it. Yes.
All right.
Please go on.
Okay. So that's
I have one question, Chandran here.
Sure, Chandran, go ahead.
Yeah, actually, last D1 is having only 8 GB, right?
Yeah.
Sorry, 8 MB.
Correct.
it will be allocating 64 MB for that 8 MB for data, or it will give only 8 MB data?
Really,
In
it
Node.
is just going to give you 8 MB data. So one had such kind of a limitations where in the very initial stage, this was also blocking 64 MB of data. But the latest version, no, it's just going to have 8 MB of data. The remaining spaces are being freed up for the rest of the data to be stored in.
Yeah, fine then.
All right. So I think we need to have some.
Hi, this is Swapna here. I have a question.
Nice now. Yeah, please go ahead.
Yeah, if your data is split in 64 MB, then it might be possible to losing the data. Like if there is a sentence, like continuous sentence, and 64 bit is in
All right,
between
valid.
the.
Okay. Yeah.
Then
So you're going to see a lot more information on that in the coming slide. Not in the coming slide, in fact, in the later session. That's a slightly an advanced topic which you're going to speak about. So basically, her question was: so think about this file as our let's bring in a new file altogether. Okay, So think about this is a Hadoop session. Hadoop session. Everyone is excited about the yellow elephant. Okay, so basically her question is think of an example. Now let's cut this into small chunks. Okay, so think about the first line. First line is 64 MB. Next line is again 64 MB. Second line, third line is again 64 MB, and the fourth one is 8 MB. All right. Okay, so now what we're going to see over here. So think of an example. So good question, Sivna. So what we're going to have over here. So this is exactly what you're talking about, right? So the first. So I have only SCS over here, and the remaining part is stored over here. Yes, there is a mechanism in Hadoop. So when I talk about this part, when I talk about this part, yes, it's valid. It is going to, the moment it sees a 64 MB, hard and fast rule, it just cuts it and then places it into the next one. It doesn't care whether you have SCS kept over there or SION or whatever it is. So the moment it sees 64 MB of data is being filled, immediately do a cut, store in the next place. Immediately, the moment 64 MB comes, cut it and store in the next place. That hard and fast rule cut is done over there. But there is some mechanism with which it's going to help you out doing the processing. So which we are going to cover in the later part of the session. Yeah. To answer your question, yes, it may make a not very meaningful data because of that cut process, but there is a mechanism to overcome such kind of non-relevant data can be processed in a much better fashion, which we're going to see in the maybe tomorrow or third or fourth session. We're going to see how exactly that will be processed. Does that answer your question?
Yes, sir. This is Kaushik here.
Hi, Kaushik.
Just hi, sir. I just want to ask one question. Like when we're dividing our data into chunks, okay?
Yeah.
So we will try to use all the possible nodes we have, right? So we'll divide accordingly, right?
That's correct.
Right. Okay, and it will also depend on the capacity of each node, right?
That's correct.
Okay.
So all those topics are not being covered over here. So we are not reached that stage. I understand. So there might be slightly. I mean, some guys who are pretty much new to big data, someone who has done some sort of a research, someone who's already worked on it. So different kind of crowds we need to cater to. So it's pretty very basic stuff is what I'll be going through. And slowly in fourth and fifth session, you might be seeing those kind of concepts being covered. Yes. So, but answer to your question, everything is yes. You're perfectly correct with all the questions that you asked.
Okay, sir. Thank you.
It all depends on the number of nodes, and this is not typically the concept. There is a little bit more stuff to it, which I don't want to complicate right now, but slowly we are going to learn it. So there is no something known as a replication factor. A duplicate file will be maintained and all those things, but time being, wipe out all those things. A very simple concept. Cut it, put it in the different computer. That's it. Different basket, if you want to think of that way. That's all we're going to deal with. Yeah. So I'm assuming everyone is assuming. Computation power, storage power, and all those things. Yes, all depends on this. Okay, so let's move on from here. So data storage has grown exponentially in the recent past, but data reading speed has not improved radically. So just one simple question for you guys. Let's remove this. Maybe it might be useful. Okay. Just wanted to make you guys some sort of 1980 for storing 1 GB of data. Okay, this is year and price per GB. Any guesses of 1980? What could be the price for storing 1 GB of data? Anyone want to take a guess of what would be the price for storing 1 GB of data in terms of dollars? Okay, because even that's easy for us. $100. 1980. Yeah, doesn't exist at that time. Might be. It definitely does exist. 1984 is the first Macintosh product that came in. I think close to 60 itself, we have computer systems available. 4 MB of data was being as big as it was brought in an aircraft. 1980. Okay, let's go for the cost. There is a slight different analysis says different, but yeah, if you take an average, it's going to be close to 0.2 million. Okay, for 2 GB of data, you need to shell out 1, 10, 100,000, 10,000 lakh. Okay, so this is the dollar price that you need to shell out for storing 1 GB of data. Okay. Yes. No, Chandan, no way close to 100. Yeah, so 1990, how much it could be? Yeah, anyway, I mean, just a random guess. Don't Google it. Okay, 18,000. Yeah, 1990, it was pretty close to that.
Make it 30,000.
Yeah, it was 9990. All right. So this was the cost for storing in 1990. Okay. Now come to 2000. How much it could be? So this is something related to most probably. Any guesses? $8. Yeah, pretty close to it. $17. Okay, 17, 18. So it depends slightly, plus or minus 3 or 4. It can result into. Now 2010.
Some 100 rupees.
Yeah. $2. 2 cents. That's correct. I mean, sorry, it's few cents. So it was 8, and it's going to be 2013 analytics is what I have. So it resulted into 2 cents. Okay. And by 2015, I guess most of the guys are giving free of 1 GB of data for free, right? So it's going to be 0.03 or something of that sort. So that's exactly the data. So this is what exactly is being told over here. So storage-wise, the price is completely reducing, right? So this is where it started with 0.3 million, and then it resulted into this as 0.03 cents. That's exactly, I mean, dollars is what exactly see as the data reduction. Whereas this characteristics of a data storage is what been exactly utilized. Okay, 1 TB के साथ 1 GB free. Yeah, I slightly know Hindi. Yeah, that's all right. The 1 GB free. Okay, 1 TB के साथ 1 GB free. Yes, nice one, Kaushik. Okay. Yes. So this component is what been really taken advantage of the many. So this all started with the Google guys. So in case if you guys are really interested, as and when I have some time or a bandwidth in our sessions, we try to share some stories. I mean, in case you guys are interested, I think David Lenz or someone has written a book, The Google Story. I don't know how many of you read it. That clearly shows the innovation that Larry Page and Sergey Brin has brought into the industry. So how exactly the computation power, all those things they have utilized. So it's a pretty good book to read. So make sure your spare time you're trying to do that. Yes, we are interested. So tell everyone to ask in general. Sure, I'll as and when we have some sort of bandwidth, I'll try to. I mean, that's something which keeps everyone excited and interesting about this interesting fact. So definitely, I'll try to share some of those which I have read or if I have gone through. So being all that said, so let's move on. We need to even keep a watch on it. Was okay. So 30 plus 20 minutes. Okay, so that should be all right. Okay, so that's some of the facts which you spoke about. So data storage has exponentially grown in terms of the cost that the data storage has drastically come down, whereas the speed with which the data is picked up and process has not. Okay, and that's some place where big data comes and played its role. So in the traditional environment, let's see how exactly a traditional environment would have worked. This is my computer, okay? And think like this is my storage area. This one is my storage, this one is my storage, and this one. This does not have any computation power. So what would have happened is the data here needs to come to this computer, okay? This needs to come to this computer, this needs to come to this computer, and then do a processing. All together, be one by one, they'll have to process and commit. So it's as good as think about you're having a washing machine, okay? And let's bring in a new figure just for making that interesting stuff. Let's pick up some of those washing machines over here now. 1, 2, or think about I have maybe I have 10 bed sheet. That's the best example. Okay, I cannot wash my bed sheet, and only one bed sheet can be washed in one machine. All right. So, and it takes me almost 1 hour to do that. Okay. So one bed sheet, it takes 1 hour. 1 hour to wash one bed sheet. Okay. And at a time, only one bed sheet can be washed. So if I have 10, not a great maths to be done over here. So it's going to take me 10 hours to wash all these things, right? That's exactly what's going to happen. So I have to wait for 10 hours for my 10 bed sheet to be washed, because I have only one bed sheet in one washing machine, right? So instead of that, what I'm going to do is I'm going to take up 10 different washing machine. I'm going to buy 10 different washing machine. 3, 4, extra 10. Okay, no need to waste time doing that. So what would happen? Very simple logic. I'll get my stuff, everything being washed in 1 hour time, right? Very simple stuff, but this simple stuff logic is what being taken, utilized in big data. So don't ignore thinking that what is he talking about, washing clothes, and this really a big data? But make sure you're trying to concentrate even that fact. And this computation factor is exactly what the processing speed or the computation that is done in terms of 100. Okay, so 1, 2, 3, 4, 5, 10 computer altogether. Each computer is capable of doing a processing over here. Okay, and then what will happen? My entire clothes are going to get washed in 1 hour time period. If I had only one computer, it would have taken me 10 hours to do it. And this is exactly the computation power used in Hadoop environment. Instead of using one huge computer, I'm utilizing a normal 10 different computer, each with computation power, process it parallelly, and then get the result back and send it back to the client. That's exactly what you're going to see over here. Okay, just close this environment. Or let's do that maybe later time period, we may have to use it. Okay, so that being said, now let's move on to what exactly. I think we may run slightly short of time for this, so we may have to cover some part of it in the next session. But that's all right. I want to have that base foundations pretty strong, so the remaining part of it will come in your fingertips. So that's all what I'm trying to do. So this is something which we spoke about MR1 and MR2. Okay, so this we are going to see. So key concept behind Hadoop is a master and a slave architecture. So what sort of architecture is being maintained? So there is one master and there are multiple slaves, right? So that's how the Hadoop environment works. So now let's reshape our figure slightly different. Okay. So all this while I was talking about this guy alone, all the three guys who's really going to do the work for you. Okay. So now you have someone else also who is going to be a master for you. So this is the computer who's going to be a master, and these are your slaves. In our real world, project manager and TL or the SSC guys, right, who really does the hard work. I mean, no, not trying to be harsh on any managers or SSCs over here. So let's name this. This is going to be my master, okay, and these are my slaves. All right. So how exactly now, this we are going to drill down a little bit more in detail, okay? So this particular data which we have stored inside this environment, inside this computer, now we are going to drill down a little bit more. So instead of this, only these three guys, I had another computer which was a master for me, okay? Master and slave, everyone is fine with master and slave, right? Now, one factor, now what am I going to call my master is another thing. I'm going to call it as name node, okay? And my slaves are known as data node. This is another data node. Oh, sorry, I should have named this data node 1. Data node 2. And this is my data node 3, okay? So I have 3 computers now, data node 1, data node 2, let's make it as one itself. Data node 1, data node 2, and data node 3, and only one node, okay? Now what we're going to see is this file, exactly this file, okay? And this is my client. When I say client, it's nothing but my normal computer. This is my computer, okay? Outside the Hadoop environment, the computer which is outside my Hadoop environment, okay? This is where this file is sitting. Let's name this file as emp.txt. It can be just a notepad, okay? emp.txt file. This is just a notepad file, but the notepad file was 200 MB in size, okay? Now let's see how exactly this file is placed inside the system. So first and the foremost thing, what this client is going to do is, he's going to, everyone understood what exactly I'm trying to do? Very simple request. I have emp.txt file, which is of 200 MB. I want to place this particular file inside my Hadoop environment. That's all my request is. I mean, that's all my requirement is. Okay. How exactly I'm going to do is what we're going to see in terms of Hadoop environment. There are 2 key concepts, master and slave. Okay. So this is my master and these are my slaves. Okay. One master and multiple slaves. My intention now is, client want to find out which is the best mobile computer out here or a node where I can place my data. So who has that information? With the name itself, you would be able to figure out, yes, the name node, who is a master, who has the complete information on this part, like what data node 1 contain, what data node 2 contain, and what data node 3 contain, and what is the space containing, and what are the remaining space available in this 3 computer. All these informations are kept in the name node. And that information is nothing but a metadata. You call it as a metadata information. Let me take a small break. Is that fine? I mean, whatever the concept is talking about, is there anyone confused with any of this concept which you discussed till now? Or is everyone in sync?
Yeah, it's
Okay.
fine.
All right. So I see a couple of guys not very clear about it. Let's repeat it. Okay. Think about, my requirement is very, very simple and straightforward. Let me name this Hadoop. Let me name this Hadoop environment. Okay. Make sure you guys are having your Complete attention over here. Hadoop environment. Okay. Sorry. This together constitute my Hadoop environment. Okay. I've not boxed this, but all these things, master plus the slave together is my Hadoop environment. Okay. Now my requirement is I have a computer, normal computer with me. Okay. Think about it as a cluster which is sitting apart from a normal environment. That is Hadoop. And I have a computer sitting outside. Okay. What my requirement is, I have a file sitting. This is my emp.txt file sitting in my computer. Okay. My requirement is I wanted to place this file inside my Hadoop environment. Requirement is very, very simple. Just copying file from one directory to another directory. As simple as that. But from here, one computer to my Hadoop, that's exactly what I wanted to copy. How exactly it's been done is what we are going to see over here now. Okay. So is that fine? So the requirement is this. Okay. So this is the only place where I can store my data. Okay, slaves are the only one who is a real hard worker for us. Man don't work. Okay, so these are the only guys who's going to do the hard work. He is the one who's going to overlook every of the stuff. Typically the PM role. So he's going to overlook is everyone doing his work. Everyone is having proper infrastructure and all those things is what the work or a job of a master. Okay, whereas the real storage, these three are the guys who's the actual one who's going to store the data. So basically who's going to store this emp.txt file. And what did we say? The moment file gets into the Hadoop environment, first and the foremost thing is I'm going to split it up. I'm going to split it into the defined 64 MB or whatever it is. Time being, we are going to consider 64 MB. Okay, so that's what the configuration file is. So I'm going to split it up basically as 64 MB, 64, 64, and 8. Okay. Now the client needs to ask this name node. I have 64, 64, 64, and 8. Where do I place my file? I have split it up like this already. So which is the place where there is some sort of availability and I want to store accordingly. So can you please get me those information is what the client is going to ask this master. Okay. The funda is master knows everything about each of this node. Its capacity, the file that is sitting inside this, every information of this slaves is available in this master. And that particular information is known as the metadata. So one key concept is master does not store any actual data. It just stores a metadata. Metadata is nothing but information about this particular computer or what exactly is there inside this computer is stored inside the master. Great question, Tiwari. So how exactly the computer master knows that? We are going to cover that. Okay. But good question. Okay. So till that concept is fine, right? This how exactly is going to store this stuff into this particular three node. Everyone is fine with that. The key use case that or the requirement that we have. So now I have split this file and this master is going to tell me, okay, I have some space available in DN1. You go ahead and store it, your A into that, okay? And then B into some space is available and the C, I have some space available in C. DN3, please go ahead and store it. And next one is available, the D1, D, please go ahead and store in DN1. So that's the information master is going to give back to the client, okay? And then directly client, based on the information given by the master, client is going to directly store this from here, this to here, this to here, and all those things. Is it fine? Okay, so that's the first process of how exactly data is being stored in the Hadoop environment. Okay, so how exactly storing is happening? I'm assuming everyone is fine with that. In case not, make sure you're listening to this recording once again and try to understand.
Yeah, it's clear,
Yeah, so,
Shadi.
all right.
You can go.
So one thing that you need to understand is, no, it's a part of, it's not the client who is actually going to do it. It's a part of master. It's a part of the process that's going to split that file. Okay, we are going to see that in detail. Okay, so now moving on, what we need to understand now is the question that you've already asked. How exactly a master knows which is the node over here, which contain what sort of an information? How exactly the master knows it? So there is something known as every time an technology is sent back to the master. Okay, so every 3 seconds. So I'm going to put a new shape over here. Every 3 seconds, a heartbeat signal is going to send by slave to the master. So each computer is going to send a heartbeat signal every 3 seconds to the name node. So key concept, data node and name node, you should be aware of it. Okay, every 3 seconds. Let's put that you register. That's 3. So 3 seconds. Okay, so every 3 seconds, and every 10th heartbeat signal. And what exactly is that? HB. We're going to write it as HB, heartbeat signal. Okay, so every 10th heartbeat signal, there is going to be a block report that's going to send along with this. Okay, so that heartbeat signal is the one with which master is going to know that this particular computer is still alive. Okay, so why still alive? Because we are not going to use an enterprise hardware. We are going to use, yesterday we discussed about it, we are going to use the commodity hardware, which is nothing but the laptop or the computer which you and me uses in your workstation or something of that sort. So anytime it's prone to a failure or it may get trashed. So this mechanism of heartbeat signal is what making it master understand, okay, my data node, data DN3 is up and running. Okay, and that information is going to go with the heartbeat signal that has been passed. And after every 10 heartbeat signal, there is going to be a board. Okay, so that's another key concept. All this small stuff is important because in case we're going for a certification and all those things, this is important stuff. So you need to understand what exactly is a block report, what exactly is a heartbeat signal. Okay, so after every 10 heartbeat signal, a block report will be sent to the name node, which contains the complete information of what are the files present over here, how many replication factor. Okay, replication factor, we are not spoken about it. So right now, park it aside. So all this information about this particular node will be present inside the master, or the name node. Okay, so that's been covered.
What is this block?
Yeah, block report is nothing but the information about this particular. So basically, think of so this particular node. You can see there is block A and there is a block D, right? So that information will be passed on to the master or the name node, telling that, okay, data node 1 contains A block as well as D block. So that information will be passed on to the name node. That is what contained in the block report.
Okay.
Yeah. So the very other question, what if the system compiling the data at the same time when it what if system compiling the data at the same time when it connected to 10 heartbeat? No, Diwali, can you elaborate on that? I didn't get what exactly is the question. Are these figures 3, 10 configurable? No, this 3 and 10 is not configurable. That's a system defined 3 heartbeat signal and 10 block report. That's a standard Hadoop steps. That's not a configurable part. Okay. Block report is generated automatically. Yes, block reports are generated automatically by the system. That's correct. What if the compiling the data at the same time when it's connected to 10 heartbeat signal? Not sure, Tewari, what exactly you're trying to ask. So maybe you can put that question, reformat that question and send it across. Okay, so that's. Yes, so block report means a snapshot of the data stored in the particular node. That's correct. The snapshot, it can't be set as a snap. So it's not the entire data. It's basically in case how much this A block, what is the size of that A block, and what exactly who is the author of it. Just a metadata. That's exactly what the block report is going to contain. Okay, so not the entire data, but the data about the data is what the block report contains. So basically, A, what is the size of it, maybe B, and where exactly it's been placed. Is there a replication available? That's exactly what it is. Yeah, Tiwari, you had some questions.
So this is Kaushik here.
Yeah, Kaushik, go ahead.
Yes. So what I'm asking is like, say there is an update in any particular node, okay? So
Okay.
After that particular data has been updated in the node, okay?
Yeah.
So so that when it sends the block report, like next 10th HBS,
Yeah.
it sends a block report. It will
Yeah.
only send the updated data, or it will send the old data plus the updated data.
Yes, it's going to send only the updated data. No, so it's going to send. There is a mechanism which, as far as block report is concerned, it's going to pick up the entire data is going to send. But there is a mechanism in which you're going to see that in an advanced session how exactly that's been done. So as far as you're concerned, entire data will be sent from here to the master node.
Okay,
So
sir,
the
and
complete.
yes,
So
sir, and
delta. Okay. Yeah.
yes,
Go ahead.
please.
Yeah, so what I'm trying to say is delta as well as the original one which is being sent prior to that also will be sent along with it. So not to complicate the process, they have just entire snapshot or the entire metadata will be sent. And there is a mechanism with which the name node can filter it. I mean, that's a little advanced topic, which you're going to see how exactly that tweaks that particular data and figure it out.
Okay, so
Yeah,
then one
go
more
ahead.
thing is, before the data is updated, and suppose
Uh-huh.
any request for the data which is not updated in the master, then like what happens? There's a drop. Like
No, I didn't get that. So the first instance you're talking about, the first time?
no, sir. What I'm asking is, suppose the node one has got one data, okay,
Okay.
and it will take 10 seconds, right? 10th HBS will be the update report will be sent to the master node,
Correct.
right? Name node.
Correct.
And I'm
Correct.
saying in between, before that 10th HPS, if one request comes which is requesting that data which has been newly added to the, DN1,
Yeah.
okay, so in that case, what happens? Like
Nothing. So the heartbeat signal has a fix. So basically, if we calculate it, it'll be maybe 30 seconds, right? The block report, because 3 into maybe if we can 30 seconds. So in that 30 seconds, whatever is that 30th instance, 30 seconds instance, whatever is the report is what it'll be sending. It's not going to look into any of those facts. The records are going to come in or whatever it is. So at that particular moment of time, whatever is the instance, that snapshot will be exactly sent. So maybe at the 60th second, there might be slight change to it, but that change information is going to again send it. So 30th seconds, there might be a little corrupted data. So that will be corrected in the 60th second and send it back to that. So on that particular instance, what is the state of this particular computer will be exactly sent to this particular system. So that's how it's maintained.
okay, sir. Thank you.
All right. Okay, let's move on slightly. Yeah, I mean,
Hi, this is Swapna here.
yes, Swapna, please go ahead.
Yeah, so these block reports are created for each data node, right?
Block reports are created for each
Every-
data node. That's correct. That's correct.
Yeah.
Yes. That's
So,
correct. Block reports are created for each data node.
so what is exactly purpose of block report? Like,
So, okay, so we are going to see that in detail in our maybe third or fourth session. But right now, what you need to understand is the complete information about this particular system. So you yourself is going to see what is the significance of this block report. So right now, what you need to understand, the current state, the entire current state of the system, or whatever is the data present in the system, all this information will be taken up, and then sent it to this name node. Okay, so you're going to see why exactly a block report in the coming, not in the coming slide, maybe in the future sessions. So what significance is a block report going to play? So let me just give it a very. So in case anytime this particular machine is going to fail, okay, there is a failure for this particular machine fails. Using that block report is what you're going to replicate that particular scenario, and that's exactly the reason for the block report. I mean, I just want to pass that information so that you don't have a sleepless night thinking at why exactly this block report. So just want to have a peaceful night's sleep for you guys. So that's exactly the reason for it. Block report is required in terms of any remote aliens. That's exactly the source with which the data will be picked up and replication will be made. So that's a little advanced topic, not advanced really. So right now it's an advanced topic for you. So maybe third or fourth session, we are going to see all those things in detail. All right.
okay.
Okay. So I guess that's clear in terms of why exactly it required in case of no require this block report. So just to answer that. So let me cover on, because otherwise I'll take up some of those questions after covering let's move forward. So master and slave, this is how exactly it's been depicted. Okay, that's exactly what we saw later. Remind me tomorrow. Okay, so this is what we saw, how exactly a master and how exactly slaves are being treated. Now, job tracker and task tracker. So that's not a time for us to get into this stage. So first, there are two components of it. Okay, how do you need to understand the Hadoop environment is? See, first, this A, D, B, and all those things. What you're talking about is how exactly I'm going to store the data. Okay, so I'm assuming everyone is fine with the storing of the data. How exactly we store the data. Now, why a data is being stored? So no one want to just keep it over there and do nothing about it, right? So once I store the data, I should make some sense out of it, and that's making sense out of a data is nothing but I'm doing some sort of a processing of this data. Okay, very simple. When I say about processing is, think about this as a big file, okay, or maybe a file where it contains employee ID, employee name, employee salary, and all those things. And we write a very simple SQL query, right? Select star from employee where group by department, where department salary and all those things, right? So those kind of a query, that's nothing but processing for me. Okay, just want to make you guys visualize what do you mean actually by processing. That's why I'm telling. So any SQL query, and that SQL query, where I'm going to run it, I'm going to run on top of this data. Okay, when I say I'm going to process it, what I'm trying to do, I have my file, so the data sitting over here. Okay, I'm going to run some program or run some query on top of this. That's exactly what I mean by processing of data. Okay, so is that clear? Processing of data. What do you mean by processing of data? So data set, the data set or this particular data is kept, and I'm going to run some queries or run some sort of programs on top of it. That's exactly a processing. All right, so let's look into that. How exactly that's done. That's a key concept. Okay, the processing part is a key concept. So storing, we are fine with it. Storage, HDFS is nothing but Hadoop distributed file system. Nothing but storage. So what we spoke about over here, this part, this is known as the storage part, and that is nothing but Hadoop distributed file system. That is the place where the storage is going to happen. So name node, data node, we explain all those things. Fine. Once the data is stored, and now how exactly I'm going to process it, that's what we're going to see. Okay, let's go back now. Now it's time for you guys to understand what things are. Okay. Now what we said, there is Hadoop 1 architecture as well as Hadoop 2 architecture, right? So when I speak about Hadoop 1 architecture, I need to come back to my figure now. Okay. So exactly like storing mechanism, there is a master and slave. Okay. In Hadoop 1, I had something known as job tracker and task tracker. Okay. Key concept. So make sure you're not yawning. Job tracker and instead of data node, I have task. Just going to make it as TT. Okay. Task tracker. Those of you guys who yawned actually might be thinking, right, do I have a webcam for seeing you guys? Yeah, task tracker. All right. So what exactly happened? So exactly like name master and data node is a slave. So for processing also, I do have a master and a slave, which is nothing but job tracker. Let's name it as JT over here in a different color. That'll be much better. Let's pick it up. Pick up. Blue we have already used. Green color. So this is job tracker. And yeah, these are task trackers. Anyway, we have named it as job tracker and task tracker. Okay. So job tracker is nothing but the master and task trackers are the slaves. So basically exactly the similar kind of function. So job tracker gives information or instructions for these guys to start processing the data. Okay, so typically if I want to say, okay, let me put this command, how exactly, so that you guys understand how things work. Okay, so what I'm going to do is, So this is a command which I'm going to give. Okay. Actually, I've written a program. Okay. So find sum of department something and made the program name as sum. Okay. Sum. Not a good color. You guys can see. Okay. Process underscore prog. Okay. So process underscore prog is the program that I've written. Okay. And emp.txt is my text file, emp.txt. Okay. And then I'm mentioning once its processing is completed, let's like this. Once the processing is completed, store it into results.txt. Okay. So think this is a command which I'm going to run. So process.program. I have written a new program which is going to process this emp.txt file. Okay. And the logic, entire logic of how exactly that needs to be processed is written in this particular program. This might be a Java program. This can be a pig script, Hive script, which you're going to see now. So time being, think about this is just a Java program. And this Java program, what is going to do? Take this data and take an average of the salary of each department. That's exactly what this program contains. And that logic is written over here. And what is the next parameter I'm going to give? I'm going to say which file I need to use for doing this processing. This is the program. This is my input file. And once my processing is completed, where should I place that particular file? Result.txt. Okay. It will be placed in one environment of my Hadoop environment. Okay. So this is exactly how it looks like. So what's going to happen? So emp.txt is placed over here, one portion of it. Here also there is one portion. Here also there is one portion. So this program, okay, I have something known as job tracker sitting over here as a master. Okay. So when the client, so who is going to send this request? You need to understand this is my computer who's going to send this request. Okay. My computer is the one who's going to send this request. Something different. Okay. So this request will be, this client will send this request to the master. Job tracker is going to take this request. And then it's going to find out where exactly this emp.txt, slightly complicated, but if you understand the concept, it's very, very simple, very straightforward stuff. So this job tracker, which is the master, is going to find out where exactly the file which he's asking for is placed. He figures it out that it's there in data node 1, data node 2, and data node 3. These are the three places where the entire small chunks of these files are being kept. Okay. So that information, he got this information. Okay. Once he has this information, what it's going to do is it's going to take this process.program. Okay. Copy it into the data node 1, copy into data node 2, copy into data node 3. Which one? This particular program is being copied to this 3 locations. And what it's going to do? It's going to process this in and every of this computer, this particular program will be getting processed. Okay. It will be processing using this A and D, right? This A and D will be processed over here. This B will be processed in the second node. This particular thing is processed in the third node. The C is processed in the third node. You saw our example of the washing machine. So that's exactly what's happening over here, right? So this is exactly what's happening. So instead of doing one single computer doing all this process, all the 10 guys are doing it all together, right? So with the parallel computation, that's exactly what's happening over here. Once the processing is completed, okay, there is a mechanism with which all data is going to be brought in together. So this will create one result. This is also going to create one result. This is also going to create one result, right? So that all result will be brought in together. Okay, and then that result is going to send back to the client. That's how exactly the processing is going to happen. Maybe slightly complicated time being. So I want you guys to go through this recording once again so that you understand. I mean, the concept is pretty clear for you guys. Okay, yeah, it's not that easy to digest stuff, but once you get this concept, it's very, very easy stuff and how exactly things work. Okay. So let's see what else is there in terms of covering. So we are talking about job tracker and task tracker, right? So this is job tracker and task tracker. So master and slave, that's part of it's fine. Okay. And let me see how much more is remaining. So this one, I don't want to cover it today because it might be a little over. Submit. Resource manager finds a loan manager admits application. Okay. So all right. So let me take up. So okay. So there was some question because as I checked, if the data is enough to store in name node. Thanks, Akash. I mean, that's exactly what you're expecting. So in case if you think that's someone, just go ahead and help others. Yeah, you're right, perfectly. The data, only the metadata. That's a key concept. Make sure you're understanding metadata is the one which is being stored in name node. No data will be stored in name node. What is the need to divide it into DN1, DN2, and DN3? Okay. Now I got cleared. No doubt now. All right, that's great. You yourself made here. Okay, only metadata. Great. Processing will be fast. That's correct. So DN1, DN2, and DN3, n number of reasons. So one thing is, Kaushik, you're perfectly right. Processing will be fast. So that's all right. The washing machine and the bed sheet example. So that's why. Otherwise, you will have to wait for your entire clothes to wash for 10 hours. So instead, you bought 10 machines and you got it cleared in 1 hour. That's one of the reasons. And something which you're going to see, this system prone to failure. So that's second part which you're going to see in the next session. So how exactly that failure scenario is being taken care is what we're going to see just because of this multiple files. Processing will be fast because hardware will be more than 3. That is 1. Yeah, that's exactly what it is. No, just refrain from those examples. So there is some more complicated stuff that needs to be spoken about that successful and all those things, because there is a little bit more complicated stuff going to come in. So that we are going to cover. I mean, not now because there is too much of things will be for your brain. So I just want to go in lesser pace. So that will be covered in your third or fourth session. So you're going to see that. How exactly that needs to be covered. Yeah. But yeah, curiosity is good. So it's good stuff. So let's see, time being, there is some more portion that needs to have. Okay. So this stuff I don't want to cover now. This will be, you guys may. So this is something which is easy to cover. Okay. So let's start with yarn stuff, which should make. So what we said, so all this thing, job tracker and the tracker, which I was talking about, was Hadoop 1 version. Okay. Now we have moved to slightly a higher version of it. There was so much of limitations and restrictions on the Hadoop 1 version. First and the foremost was this is the number of computer or the node I'm talking about. In Hadoop 1 version, the maximum they can extend up to was 4,000 nodes. Okay. 4,000 nodes. So this is what the Yahoo has tested, the number of nodes for Hadoop 1 version. Okay. And then they understood that 4,000 nodes is not the maximum they need to go for. They need to go much beyond it. They need to have more capacity in terms of infrastructure, how exactly that needs to be stored and everything. So with the Hadoop 1.star version, they cannot go beyond the 4,000 nodes. Okay, so that was one of the prime limitations, one of the very, very predominant limitation in terms of the Hadoop 1.star is concerned. So when we went to the Hadoop 2.star, it has been tested more than with 10,000 nodes is already been tested for Hadoop 2. So I don't have the latest figure with me. And what are the key differences over here? So job tracker, what you see over here is being replaced by something known as, Okay, one thing which you need to understand. So our intention is not covering Hadoop 1 version, but still something which I want to tell is this job tracker, even though we call it as a manager, he was the guy who was taking too many responsibilities over here. Okay, in Hadoop 1. He had to make sure that whoever is coming from the request, okay, he need to find out where the files are being placed, how exactly this process.program, right? This program needs to be placed over here. In case that program is not successfully running, he need to make sure it's been killed over here. He need to bring it over here. There are too much of burden on the job tracker. Okay, project managers was literally frustrated with his work. That's how exactly the Hadoop 1.star was working. Okay. In order to overcome such limitations and such hindrance over here, it came up with no, it's just one single job tracker. No, it's not another job tracker. We came up with Hadoop 2 version where it is the new guy is known as resource manager. Okay, let's name him maybe what color? Pink, blue, yellow can be seen. It's red in color, but let's make him. So resource manager. Okay, he's known as resource manager. And this TT guy is known as what is the resource manager corresponding? Node manager. Okay, so the slave is known as node manager. Okay, and the master is known as the resource manager, node manager. Okay, so resource manager and node manager. The master was resource manager, and there was something known as do I need to cover? And I think that might be a little. Yeah, it's not mentioned, right? Yeah, only resource manager and node manager is mentioned over here. So I'm assuming the remaining part we can cover. Okay, so basically what has happened over here is job trackers overburdening stuff is being controlled by resource manager. So resource manager takes care of only picking up which particular location this process program needs to be placed. It will find out from node manager where exactly this particular AD guy is sitting. Take this process.program, okay, and this just put it over here in the data node 1, data node 2, and in data node 3. That's all he does it. Okay, in case of any failure, there is another guy which we are not. That's an alien for us now. Okay, so he is responsible for doing all this task. Okay, we are not going to introduce him. He is a late entry, maybe special appearance in the 4th session. He's going to come in. Okay, so that guy is going to do all the additional burden. So here, resource manager back to his normal self, enjoying his life. Just take up the responsibility. I mean, take up the job, place it over here. Take this not over here. Place the other job, place it over here. That's all he's going to do. All right. And there is some other guy who's going to do the hard work of finding out which node is failing, what needs to be done in case of failure, what data needs to be kept, everything, each and every responsibility is being split across to the multiple guy, and that's how exactly it's going to get processed. Yeah, late entry guy. I think we have 7 more minutes left. So what I would recommend is this today's topic might be a slightly, slight bounces, but concept wise is pretty simple. It's the first time you're going to see it. That's why you may find it that's slightly complicated in some of the terms. Okay, and how exactly it's been done. But go through this recording again, pause it, repeat it, go back and see it again. I mean, it's very simple and straightforward concepts. So so you should be able to figure out what exactly is. Whether by the time you come for the next sessions, I mean, I'll be just brushing through some of these concepts, so it'll be much easier for you to play around with. Yeah, that's fine. That's much expected, Diwali. So unless and until you are an alien from some other with the 2 antennas getting and zoomed everything what I say to be, so that's fine. Yeah.
So this,
Any question?
when we're talking about a resource manager and node manager, are these
Yeah.
part of Hadoop 2.star or they are part of Yarn?
This is Hadoop 2.star is nothing but the Yarn stuff. That's how exactly Hadoop 2.star is made. So that's yeah, both are one and the same. It's interchangeable interchangeable stuff.
Okay, sir.
Yeah. Okay. All right, I'll get them from Cisco. Yes, Tiwari, you may have to. Okay. Okay, so now the only concept that we are going to park aside or bring it up the next session is, because I don't want to, this is something which you're going to cover next. This is exactly how the job is getting submitted. So what we're going to see is the diagram which I showed over here. Where is he? Yeah. So this one. So this, how exactly a client is submitting the node, and then how exactly it's getting distributed and processing. That's what being told over here, which we are going to cover in the next session. So client calls the submit job requests, resource manager returns application ID, submits it. We're going to see that. I mean, don't overburden your brain. Okay, so this is this process of job initiation. I want to see a little bit more in detail. Some of those questions, let's see. Before that, we have covered everything. Yeah, so this is something I would like to elaborate it a little bit more in detail. Okay, so you need to know a little bit more this stuff in detail. So this is a question which someone has asked: how exactly the data which is going, right, metadata, how exactly metadata coming over here, how exactly that is getting processed? Will this slide answer that for you? This is also a slightly complicated stuff, but don't worry, I have some specific diagrams for my previous batch we made, which they really appreciated. So hope you guys also will be able to appreciate those stuff and will be able to capture those stuff in much easily. Yes, I don't want to bring in anything new because it's only how many more minutes? 4 minutes time. So what is the approach for solve big data problem? What are the core components of do all network nodes work all the time in Hadoop cluster? We are going to see your answer for all these things. What is the role of master node in the Hadoop cluster? Should be knowing that. Can slave node directly communicate with each other? You're going to see that. How is the concept of high availability more efficient than secondary main node concept? This is also not covered. So we have to do this in the next session. What you're going to see in the next session? SCFC data flow, high level architecture, processing constraints. So some of this, yeah, okay. So this is the answer for someone, who was that? I think Swapna started it, I guess, and someone else also had, I think Tiwari or someone asked, right? Processing on input split. This is the guy who's going to help you in case in between the words you cut it into two different pieces. He is the savior for you, input split, which we are going to see. Time being, no need to bother about it. Okay, so that's all. So in case if you're stuck with any of the technical issues, make sure your first point of contact is going to be support@acadgill.com. There's a complete full-fledged technical team available for your support. Okay, so as and when they figure out something, so make sure you're giving very, very detailed explanation of what's going wrong, what you're trying to do, and what is the stuff that you're not able to accomplish. So that information, just make sure you're providing to them so that they'll be able to help you out as elaborate as possible to provide those information. Let's break for open the floor for some of those questions. Only 2 minutes available, but yeah, anyone with any burning questions, which you'll have a sleepless night. Yeah, go ahead, please.
I don't have any question, but I wanted to say something. It would be easy for me if you go slide by slide. I mean to say, I'm giving you a feedback little. So if you go slide by slide, then while going your recording after some time, it would be easy for me to recover what all slides have been covered in the session and what all topics are pending for the next.
All right. So basically, when you sit slide by slide, I mean, aren't we not going slide by slide? So you meant to say,
if you want to skip, if you want to skip some of the slide, I can note it down. Okay, this slide is covered in the theory what we discussed. So that's okay. But sometimes you are going to 35 page, then coming back to 18. It was tough for me to recognize.
Correct. So the issue where I went is, so there is something known as a storage. Okay, So first we need to understand about, so I mean, I guess this is the point you're talking about. So we skipped here, and here, and then came back to this part, right?
Map reduce. Yes,
Yeah,
map reduce.
yeah. So the reason behind it is this is slightly missing that sequence. Okay. If I come over here without explaining about storage, if I start talking about job tracker and task tracker, you may not able to really capture it. So that's the reason. So otherwise, we're going to go in
So
very
are you
sequence
saying
type
something
manner.
like content is not structured properly?
No, it's not the content structured properly. So basically, what happened is, so in our initial time, we had a slide in between this, but that
Okay.
turned out to be a very complicated one. So we had to rearrange stuff and all those things. So maybe that could. I'll take this as a update also. So slightly maybe, yeah. So only thing is what I wanted to do is, so before bringing in processing, I just want to bring in make you guys pretty aware of the storage part. So that's all I was trying to do. Yeah, but pretty good street deck. So let me keep a note of slide by. Yeah, but anyway, I mean that is exactly my plan. So slide by slide is what my plan. But anyway, please go ahead and make sure any feedback that you feel free to do that so that I understand, because it's more you need to take advantage of this program rather than my.
Okay. So I'll go through the recording as well as I'll go through the topics. So whatever the pending points would be there in the next class, I'll be highlighting all that.
Sure. Please go ahead and do that. Yeah.
So I don't want to miss anything.
Definitely not. You need to. Yeah.
Sure. Other than this, yeah. In that topic, you were telling something. There is a difference in between Hadoop 1 and Hadoop 2. So while going through all the slides or whatever the theory you were telling about, it was mainly just a name difference. That's it.
No, not really the main.
Yeah.
So some of the limitations that we're talking about, right? The 4,000 nodes, they were not able to expand beyond the 4,000.
I understood the limitation. Yeah.
So and Hadoop 1 was just map reduce. So that's map reduce part is something which you're going to cover in the next part. So I mean, I can push in, because if I start pushing in most of the component, I think it might be slightly tough for you guys to register. So initially, I wanted to make it as slow as possible, as everyone gets fed up. I mean, so not fed up. Feed data into as slow as possible, and then we are able to pace it up. So that foundation stuff is very, very critical part over here. But slowly, then fourth, fifth sessions, you should be able to take it up in a fingertip kind of thing. So it makes things much easier for you guys to capture.
I'm totally getting your point. But even if
sorry, your voice breaking. Hold on a minute. Let me mute you.
Total 46 slides are there, and 46 slides in a one thing.
It was very, very tough to make out what he said.
Hello. Yeah, I'm back. That was a disconnection from my network. Am I audible now?
Yes, you're audible now. Yeah.
Okay. So I was saying that the content in your PPT is of 46 pages, and it's very tough for running all the 46 pages with some theory or concepts to be discussed.
That's correct.
Probably we have to. Anyways, this is your internal how you structure this content. One more thing. Do you have any other class starting from 10:30?
Starting from 10:30? No, I do need to get some sleep, so definitely not.
Okay. Okay.
Yeah, I don't have. I mean, 10:30 is the maximum, so I don't have any more sessions.
Understood. No problem. But
sorry.
It's okay. Please go on.
Yeah, there might be an early morning sessions. I guess. I mean, I'm not sure which is currently running in parallel, because there are multiple sessions running in parallel. So, Tiwari, I'm Shaji here. Vikal Jain Heyman, Hadoop is the course for which we need Java as prerequisite. It's some bit harder. SF man. Okay. Sorry, I forgot your name. Okay, Shaji. Yeah. Yeah, I spell it as SHAJEE. That's how I spell my name. Yeah. Okay, so in case if nothing more, I don't want to make you guys wait for further.
I have one question. This is Swapna here.
Yes, Swapna, please go ahead.
In master, we have three things: name node, job tracker, and resource manager. So these three will be talking each other. Like name node will be informing job tracker about what are the information it is going to assign to.
Yeah, but job tracker or resource manager, they are mutually exclusive. So either it's going to be Hadoop 1 version or it's going to be Hadoop 2 version. Okay. So you may have either job tracker or you may have resource manager. So both know. So that's why I was trying to put on top of that particular job tracker, right? So name node, yes, name node is the master for storage, whereas job tracker or resource manager is the master for processing, right? So job tracker was Hadoop 1 version, whereas resource manager was Hadoop 2 version. Does that make sense?
Yeah. So how job tracker
Okay,
knows?
They can interact with each other. That's correct. They can interact with each other.
Okay.
Yeah. So maybe I mean you don't sound to be convinced, but those stuff is going to come in third or fourth session. So we are going to see how exactly they talk to each other and how exactly the processing is going to happen more in detail. Yeah. So don't worry. We are going to cover all those stuff.
I can give a small example here. So the example you were talking about, some 10 different washing machines were there, and I'm the one who can distribute my bed sheets into the different machines. So I'm the one who can decide which stuff to be assigned to which different machine. Second thing is the same instruction, the same washing instruction to be given to all different machines.
Okay. The name node stuff is what you're going to talk about.
Yes, so there is no relation between the different washing machines, but the instructor will give the same instructions to all the machines, whereas the data to be loaded with respect to the capacity of the machines.
Yeah. Tiwari, so are you? So the moment you log into your dashboard, you don't have those slides with you. You don't get these slides in your stuff. So are you not able to see the slides at all? Yeah, that should be. So it's exactly the same kind of. Only thing is, I'll have some multiple options than you. Otherwise, it's exactly the same session which both of us are seeing. So anyway, Akash has confirmed that those are there. So you may have to explore more on your dashboard. All contents are there in the dashboard. Yeah. So there are more people to support me. You're losing vote. Yes, I'm going to the ghost content reactor. Okay, so in case we're not able to see, there might be there is some issue with your system or something. Shoot. Yes, that's correct. So the tabs, or you may have to play around with those dashboards more. Yeah. So for the remaining folks, yeah, I don't have anything more to. Yeah, and that's something which I wanted to cover. I think I covered from the first sessions, right? So in case of any issues, make sure you are getting in touch with our support desk. Let me share that real quick so that, yeah, support@techadgil.com. This is our tech support desk. So we are very, very support guys. Okay. Okay, so I don't want to hold you guys any further. So in case nothing more, so see you guys. So just make sure you're looking into that assignments or any of those part in case required. I'm not sure. Not in case required. I'm not sure if there is an assignment for this session. I don't think, but I think you have to set up your environment before the next session. So that's where we are going to start playing around with the environment and stuff like that. So it's much better. You have your environment, everything ready, so that we can in parallel play around with the environment and all those things. Yeah. Okay. So you all guys have a wonderful weekend too. So speak to you on next Tuesday. All right.
Thanks, Shazi.
Good
Yeah,
night,
good
guys.
night.
Yeah.
Have a
Thank
good
you.
weekend. Bye-bye.
Same to you. Yeah. Cheers. Bye. Thanks, everyone.